What if one of the most basic questions in physics is still not truly answered? Why does mass create gravity? At first, it sounds almost too simple to matter, like something you were supposed to accept in school without thinking twice. Mass has gravity because that's what mass does. That answer feels neat, complete, and safe. It closes the conversation before it even really starts. But the moment you sit with it for more than a second, that explanation starts to fall apart, because it doesn't actually explain anything. It just repeats the fact in different words. It's like saying, something happens because it happens. And once you notice that, the question stops being simple. It becomes unsettling in a quiet way. Because now you're forced to ask something deeper. Why should mass do anything at all? Why should the presence of matter influence anything beyond itself, especially across empty space? Why should one object, separated by millions or even billions of kilometers, affect another without any visible connection? In everyday life, nothing works like that. Things only move when they are pushed or pulled through direct contact. You expect motion to come from interaction you can see. A hand pushing a door, a foot kicking a ball, a machine transferring force through contact. That's the kind of reality we are used to. But gravity doesn't behave like that at all. There is no visible link, no rope, no surface, no mechanism you can point to. And yet, everything responds to it. The earth holds you down without touching you. The moon moves oceans without ever making contact. The sun keeps planets in orbit across distances so vast they are almost impossible to imagine. And all of it happens silently, constantly, invisibly. We call it normal, but it isn't normal at all. It's something far stranger than we usually admit. Because once you stop accepting gravity as just how things work, the entire picture changes. It stops being a background rule and becomes a real mystery, a deep one that sits at the core of how reality itself behaves. At that point, the question is no longer just what gravity does. It becomes why it exists at all. Why mass, out of all possible properties of matter, has this specific ability to shape motion across space. Why it doesn't just remain passive and inert, but instead seems to influence everything around it. And this is where curiosity begins to shift. You're no longer just absorbing an explanation, you're questioning the foundation underneath it. You're moving from memorizing facts into actually thinking about what those facts mean. Because gravity pulls is not an explanation, it's a description. It tells you what happens, not why it happens, and that difference is everything. Once you see that gap, it's impossible to ignore. Every time you hear a simple explanation, you start noticing what's missing. The deeper cause, the hidden mechanism, the unanswered why underneath the how. And strangely, the deeper you go, the more uncomfortable it becomes. Because you begin to realize something surprising. The answer you were expecting doesn't really exist in a simple form. Not yet. Even in modern physics, where gravity can be calculated with extreme precision, where orbits can be predicted, where black holes can be modeled, the deeper explanation is still incomplete. We can describe how gravity behaves with incredible accuracy, but when it comes to why mass produces gravity in the first place, the answer is still not fully there. And that realization changes everything. It means this isn't a basic question at all. It's one of the deepest questions in science. And once you see it that way, the entire topic opens up. This is where the real journey begins. And in the next part, we'll go into what happens when science itself starts to struggle with this question, and why even our best theories still leave something important unexplained. And in the next part, we'll go into what happens when science itself starts to struggle with this question, and why even our best theories still leave something important unexplained. Because once you reach this point, a new thought naturally appears. Maybe the answer does exist somewhere, and you just haven't learned enough yet. Maybe if you study deeper, read more advanced physics, explore the equations behind gravity, everything will finally make sense. That belief feels reasonable. It feels like knowledge is just one step away. But then something unexpected happens. The deeper you go into physics, the more precise the descriptions become, yet the core mystery remains untouched. Science becomes incredibly powerful at telling you how gravity works. It gives you equations that can predict motion with astonishing accuracy. It allows us to send satellites into orbit, navigate spacecraft across the solar system, and even detect invisible objects like black holes. That level of precision is one of the greatest achievements in human history. But even with all that success, the question still stands exactly where it was. Why? Why should mass curve anything at all? Why should space respond to matter? Why is the universe built in such a way that simply existing with mass changes how everything around you behaves? And this is where things become surprising. Physics, as advanced as it is, does not fully answer that question. It shows you the structure, it reveals the patterns, it gives you the rules, but the deeper reason behind those rules remains unclear. That can feel strange at first because we are used to thinking of science as something that explains everything. If something is understood, we expect the why to be clear. But here, you begin to see that understanding comes in layers. There is a difference between knowing how something behaves and knowing why it exists in that form. And gravity sits right at that boundary. Because we can describe it perfectly in terms of behavior. We can measure it, calculate it, and predict it. But when we ask why mass creates gravity in the first place, we step into territory that is still open, still uncertain. And that realization is not a weakness of science. It is a reflection of how deep this question really is. Because now gravity is no longer just a solved problem. It becomes a doorway into something much larger. It points toward a deeper layer of reality that we are still trying to understand. And that should not discourage you. It should do the opposite. It should pull you in. Because it means the story is not finished. It means there are still discoveries waiting to be made. It means that even in something as familiar as gravity, there are unanswered questions that matter. And now you are standing right in front of one of them. Because when you ask why mass creates gravity, you are not asking a closed question. You are opening a door into deeper thinking, into a space where certainty fades and curiosity becomes stronger. And this is exactly where real progress begins. Not by repeating what is already known, but by pushing into what is not fully understood. Then something even more interesting begins to happen. Your perspective starts to shift. You stop seeing gravity as just a force between objects, and you begin to question the framework behind it. Because what if gravity is not a force in the way we usually imagine? What if it is not about objects pulling on each other across space at all? That idea might sound strange at first, but it leads to one of the most important breakthroughs in physics. A way of looking at gravity that completely changes how we understand it. And once you see it, you can't go back to the old way of thinking. Because in the next part, we are going to explore a completely different perspective, one that replaces the idea of force with something much deeper, and shows that gravity might not be something happening in space, but something happening to space itself. Because in the next part, we are going to explore a completely different perspective, one that replaces the idea of force with something much deeper, and shows that gravity might not be something happening in space, but something happening to space itself. And this is where everything changes. Because once you stop imagining gravity as an invisible pull between objects, a new picture begins to form. Instead of thinking about forces reaching across empty distance, you start thinking about the structure of reality itself. You begin to see that space is not just an empty stage where things happen. It is something active, something that can bend, stretch, and respond. This idea is at the heart of modern physics. It tells us that gravity is not really a force in the traditional sense. It is the result of how mass shapes space and time. At first, that sounds abstract. But if you slow down and think about it, it changes everything about how you see motion. Because now, objects are not being pulled in the way you might imagine. Instead, they are simply following the paths available to them, paths that have been altered by the presence of mass. In other words, mass does not reach out and grab things. It changes the geometry of the universe around it. And that shift in perspective is powerful, because it removes the need for a mysterious, invisible force acting at a distance. Instead, it replaces it with something more fundamental, the shape of reality itself. Think about how straight lines work in your everyday experience. You expect them to stay straight. You expect space to be flat and predictable. But in reality, space is not fixed in that way. It can curve. And when it curves, the paths objects follow also curve. So when a planet orbits a star, it is not being pulled by a hidden force. It is moving along a curved path in a space that has been shaped by the star's mass. That idea might feel unfamiliar at first, but it explains something important. It shows how motion can happen without direct contact, without visible interaction, without anything physically connecting the objects. Because the connection is not between the objects themselves. It is in the space they exist in. And once you see that, gravity becomes something entirely different. It is no longer about attraction. It is about geometry. But even this deeper understanding does not fully answer the original question, because now we have moved the mystery one step further. Instead of asking why objects pull on each other, we are now asking why mass changes space at all. Why should matter affect the structure of reality itself? Why should the presence of mass bend space and alter time? And once again, the answer is not fully clear. Because even though this model explains how gravity works with incredible accuracy, it still does not explain why the universe behaves this way at the most fundamental level. And that realization is important, because it shows you that progress in science does not always remove mystery. Sometimes it reveals deeper layers of it. You start with a simple question, you find a better explanation, and then that explanation opens the door to an even deeper question. That is exactly what is happening here. Because now gravity is no longer just about motion or force. It becomes a question about the nature of space and time themselves, about why reality has the structure it does. And the more you think about it, the more incredible it becomes. Because every object with mass, no matter how small, is contributing to this process. It is shaping the space around it, even if the effect is tiny. That means the entire universe is a connected system, where everything influences everything else through the structure of space itself. Nothing is truly isolated. Everything participates. And that idea is both simple and profound, because it shows that the universe is not just a collection of separate objects. It is a unified system, connected through the geometry of reality. But even with this understanding, the core question remains. Why should mass have this role at all? Why should something as simple as matter carry the ability to reshape space and time? And as we move forward, the question becomes even bigger, because now we are no longer just talking about gravity, we are starting to ask something deeper about the universe itself. In the next part, we'll go even further into that idea and explore what this question reveals about the limits of our knowledge and why the answer might lie beyond what we currently understand. In the next part, we'll go even further into that idea and explore what this question reveals about the limits of our knowledge and why the answer might lie beyond what we currently understand. Because once you accept that gravity is not just a force, but a result of how space and time behave, something deeper begins to unfold. You start to realize that the question is no longer just about physics, formulas, or equations. It becomes a question about the foundation of reality itself. Why does space respond to mass? Why does time slow down in the presence of matter? Why is the universe built on this connection between matter and geometry? At this point, the question expands far beyond gravity. It becomes a question about existence, about why the universe is structured the way it is, instead of some completely different way. And this is where the limits of our understanding start to become visible. Because in science, there is a pattern. We observe something, we describe how it behaves, then we build models that predict it with precision. And for gravity, we have done all of that successfully. We can track planets, predict eclipses, simulate black holes, and even measure tiny distortions in space caused by massive objects. But describing behavior is not the same as explaining origin. And here is where things become truly interesting. Because when physicists try to go deeper, when they try to explain why space and time behave this way, they start to encounter something unexpected. The theories begin to break down. At very large scales, gravity works beautifully. At very small scales, the world is described by quantum physics, a completely different framework that explains how particles behave. But when you try to combine these two descriptions into one complete picture, something doesn't fit. Gravity does not easily merge with the rules that govern the smallest parts of reality. And that tension is one of the biggest unsolved problems in science today. It suggests that our current understanding, as powerful as it is still incomplete. There is something deeper that connects these ideas, something we have not fully discovered yet. And that brings us back to the original question in a new way. Because now, asking why mass creates gravity is not just about gravity itself. It is about what lies beneath space and time. It is about whether space is truly fundamental, or if it is something that emerges from an even deeper level of reality. That idea might seem abstract, but it has powerful implications. Because if space itself is not fundamental, then gravity is not just a property of matter. It is a clue, a signal pointing towards something deeper, something hidden. And this is where imagination begins to play a role, alongside science. Because to move forward, physicists are exploring ideas that go beyond traditional concepts. Some theories suggest that space and time might emerge from networks of information. Others propose that reality at its deepest level is not made of particles, but of relationships or connections. In these views, gravity is no longer just a force or even just geometry. It becomes part of a deeper structure, something that arises from how the universe is built at its most basic level. And that is a profound shift, because now mass might not just bend space. It might be connected to the very process that creates space in the first place. And if that is true, then understanding gravity would mean understanding the origin of reality itself. That is why this question matters so much. It is not just a curiosity, it is a doorway into one of the deepest mysteries we can explore. And the more you think about it, the more you realize how close you are to that mystery. Because gravity is not something distant or abstract. It is something you experience every moment of your life. It is part of everything around you. Yet behind that familiar experience lies something we do not fully understand. And that contrast is powerful, because it shows that even the most ordinary parts of reality can hide the deepest questions. So now the journey takes another step forward. Because in the next part, we will explore what this mystery means for us as thinkers and learners, and why not having a final answer might be the most important part of all. Because in the next part, we will explore what this mystery means for us as thinkers and learners, and why not having a final answer might be the most important part of all. And this is where the perspective shifts again, but this time it becomes personal. Because once you understand that even something as fundamental as gravity is not fully explained, it changes how you look at knowledge itself. You begin to see that understanding is not about collecting final answers, it is about exploring deeper questions. At first, that idea can feel uncomfortable. We are trained to believe that learning leads to certainty, that if we study enough, we will eventually reach a point where everything becomes clear and complete. But here, you are faced with something different. You are faced with a question that remains open, even at the highest levels of science. And instead of being a weakness, that openness is actually what drives progress. Because every major breakthrough in history started with someone refusing to accept a surface-level explanation. Someone looked at something that everyone else considered obvious and asked, "Is that really enough?" That simple act of questioning is what pushes knowledge forward. And that is exactly where you are right now. Because when you ask why mass creates gravity, you are not rejecting science. You are engaging with it at a deeper level. You are doing what scientists do. You are looking beyond the description and searching for the underlying reason. And that shift is powerful. Because now, every idea becomes something you can explore, not just something you memorize. Every explanation becomes something you can test, question, and build upon. You are no longer passively accepting knowledge. You are actively participating in it. And that changes everything. Because once you develop that mindset, it does not stop with gravity. It extends to everything you learn. Every concept becomes an opportunity to go deeper. Every assumption becomes something worth examining. And suddenly, the world feels different. Instead of being a place filled with fixed facts, it becomes a landscape of open questions. A place where curiosity matters more than certainty. A place where not knowing something is not a failure, but the starting point of discovery. And that is where real excitement begins. Because now, the mystery of gravity is no longer frustrating. It becomes inspiring. It becomes a reminder that there are still things to uncover, still ideas waiting to be understood, still layers of reality we have not fully explored. And you are part of that process. Because the same curiosity that led to our current understanding is the same curiosity that will lead to future discoveries. The same questions that seem simple today could lead to breakthroughs tomorrow. And that possibility is powerful. Because it means that the story is not finished. It means that what we know today is only part of a larger picture. And it means that there is still room for new ideas, new perspectives, and new ways of understanding the universe. So instead of looking for a final answer, you begin to appreciate the question itself. Because questions like this do something important. They change how you think. They push you beyond simple explanations and into deeper reasoning. They force you to confront the limits of what is known and to imagine what might lie beyond. And that is where growth happens. Because the goal is not just to find answers. It is to develop the ability to ask better questions. Questions that lead somewhere new. Questions that challenge assumptions. Questions that open doors. And gravity, as simple as it may seem, is one of those doors. It is a reminder that even the most familiar things can hold the deepest mysteries. That even something you experience every day can still be part of an unsolved problem. And that realization is not just interesting, it is transformative. Because now, you are no longer just learning about the universe, you are exploring it. And in the final part, we are going to bring everything together and face the most important conclusion of all, what it really means that we still don't fully know why mass creates gravity. And in the final part, we are going to bring everything together and face the most important conclusion of all. What it really means that we still don't fully know why mass creates gravity. Because after everything we've explored, all the ideas, all the perspectives, all the layers of understanding, we arrive back at the same simple question: why? Why does mass create gravity? Why does the universe behave this way? And the honest answer is something many people don't expect. We don't fully know. At first, that might sound disappointing. You might expect that with all the progress in science, with all the equations, discoveries, and technology, we would have a complete answer. Something final, something clear, something that closes the question once and for all. But we don't. And that is not a failure. That is the most important part of this entire journey. Because it means the story is still unfolding. It means discovery is still happening. It means there are still questions that matter, still mysteries that challenge us, still ideas waiting to be uncovered. And that changes how you see everything. Because now, gravity is no longer just a concept you learn and move on from. It becomes a reminder that even the most familiar parts of reality can hold something deeper, something not yet fully understood. And that realization connects you to something bigger. Because throughout history, every major breakthrough began with a question like this. Someone looked at something simple, something everyone accepted, and refused to stop there. They asked why, even when there was no clear answer. They kept pushing, kept exploring, kept thinking beyond what was known. And that is exactly where you are now. You are standing at the edge of understanding, not outside of knowledge, but right at its boundary, looking into what we know and what we still don't. Because understanding how something works is one level, but understanding why it works, that is something deeper. That is where true insight begins. And this question about gravity is one of those rare questions that does more than just give information. It changes how you think. It shifts your perspective from seeing the universe as a set of fixed rules to seeing it as something dynamic, something still being explored. Because now, when you look at gravity, you don't just see objects falling or planets orbiting, you see the structure behind it. You think about space, about time, about the hidden framework that connects everything, and then you realize something even more important. You are not separate from it. You are part of the same system, made of the same matter, following the same laws. The gravity that holds galaxies together is the same gravity acting on you right now. The same mystery exists in everything, including you. And that connection is powerful, because it means that understanding the universe is not just about looking outward, it is also about understanding the reality you exist within. The same rules shaping stars and planets are shaping your world, your motion, your experience. And that makes this question more than just scientific. It becomes something meaningful. Because now curiosity is not just about learning facts. It becomes about exploration, about pushing beyond what is known, about asking questions that don't have easy answers. And that is where real progress begins. Not with certainty, but with curiosity that refuses to fade, with questions that stay in your mind and keep pushing you forward, with a desire to understand something deeper than what is immediately visible. Because every time we ask better questions, we move closer to better answers. And maybe one day, someone will uncover the deeper reason behind gravity. Someone will discover why mass shapes space, why reality is built this way, why the universe connects matter and geometry so fundamentally. And when that happens, it will change everything. The way we understand physics, the way we understand reality, even the way we understand existence itself. But until that moment arrives, the question remains open. Waiting, challenging, inviting someone to explore it. And that is what makes this so important.